students, welcome back once again to math session. In today's video lesson, we are going to deal about the exercise 12.2 problems, right, of the application of trigonometry chapter 12 of class 10th. Now, we have completed the introductory part of the application of trigonometry, exercise 12.1 also. Right. Now today we will be discussing exercise 12.2 and in this exercise we have quite many problems, 10 problems. All these 10 problems are very important as far as examination is concerned. We get essay questions from these exercise. Right. Let's get started with the first problem. I'll read it for you. 12.2, the first problem. Now, all the while we were dealing with only one triangle, isn't it? We were dealing with one triangle. In 12.1, we were dealing with only one triangle. Let's deal with the two triangles. How to find the heights and distances using two triangles. Like the first one, a TV tower stands vertically on the side of a road. From a point on the other side, directly opposite to the tower, the angle of elevation of the top of the tower is 60 degrees. From another point 10 meters away from this point, on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. Find the height of the tower and the width of the road. Here, clearly, you need to understand what is given and what is being asked. Okay. The problems are very complicated, but if you get the diagram, if you visualize the diagram, you can easily solve it, right? Now, visualizing the diagram itself is the main part in these problems. Here, a TV tower stands vertically on the side of a road, right? Let us draw a TV tower here. Let me suppose this as a TV tower. Right, here. The next one, vertical on the side of the, from a point on the other side directly opposite to the tower, the angle of elevation to the top of the tower is 60 degrees. So, the angle, it's 60 degrees here, and if this is a TV tower and this is a point of observation on the road. Now, let this be the width of the road, okay. I'll suppose the width of the road as x, okay. So, this is road width. Now, if they have moved to another point on the same side at about 10 meters, right, the angle of elevation naturally will decrease, okay. If you are moving away from the object or the tower or the building, if you are moving away, the angle will be decreased. So, the angle of elevation given in the problem is 30 degrees, right. It has been decreased. Now, how many meters? The point of observation from here, when observed to the top of the TV tower, it was 60 degrees. After moving 10 meters, this is 10 meters, observation from this point, we get it as angle of elevation as 30 degrees. Now, asked is what is the height of the TV tower and the width of the road. Okay, these two are the points of observations. Let us name this TV tower. So, clearly it is vertical erect to the road, isn't it? So, let this be AB, okay, and this is first point of observation, this is the second point of observation, let this be C and D. So, we got the right angle triangle. Now, from the previous exercise, we were doing using only one triangle. Now, in this exercise, we will be using two triangles, right, on same side or on the either side. Likewise, we will be getting using two triangles, right, here. Now, from this information, we can take this as a right angle, ABC. Again, there is another right angle, ABD also. So, two triangles. So, let me start this here. Tan. Why am I taking tan? Because opposite and adjacent, right? So, I am taking tan. So, tan 60 degrees is equal to so, the TV tower here, let me suppose it as H. Okay, since I have supposed the road width as X, let TV tower, so let us write, let TV tower be H meters, right, and road width width of the road or road width equal to x meters. So tan 60 is opposite by adjacent. So opposite is h, by adjacent is x, right? Now tan 60 value is root 3, right? That is equal to h by x. Now just cross multiply it. H is equal to root 3x. Let me suppose this as equation 1. Okay. So from two triangles we will be getting two equations, and solving two equations we can get the solution. Now here let me take another triangle here. Here I'll mention it as in triangle ABC. Okay, comma, here again in triangle ABD. Okay, see the other triangle. Let's find the tan. Tan 30 degrees is equal to opposite by the adjacent. So adjacent is x plus 10, right? So opposite is the same, h, adjacent is x plus 10, right? Now tan 30 degrees is 1 by root 3 and h by x plus 10. So just cross multiply, it comes to x plus 10 is equal to root 3h. Now here I got the equation in h. So let me get the equation in h again. H is equal to x plus 10 by root 3. Let us suppose this as equation 1 and 2. So h I got root 3x, h I got x plus 10 by root 3. So I'll equate these two, okay? From equation 1 and 2, from equations 1 and 2, we get, so when you equate these two, LHS part is equal, so RHS part will equate. So root 3x is equal to x plus 10 by root 3. So clearly see that x is not under the root. Okay. Now cross multiply. Root 3 into root 3 comes to 3. 3x is equal to x plus 10. So bring this x to this side. I'll write it here to the top. 3x minus x is equal to 10. So 2x is equal to 10. So x is equal to 10 upon 2, that is 5. Now what is x? The road width. So road width is 5 meters. Now with this we will find h. Now we have substituting in equation 1. Substitute x in equation 1. Why? Because 1 is h is equal to root 3 x. Now h value I want root 3 into 5. So that comes to 5 into 1.732. Root 3 value 1.732. And students, you need to remember root 2, root 3, root 5. Root 2 is 1.414. Root 3 is 1.732. Root 5 is 2.236. So these three are standard. So if you remember, you can easily calculate. Now this I'll write it here, the rough part. Calculations 1.732 multiplied by 5. So 10, 15, 16, so 35, 36, 3, 5 ones 5, 8. So point, that comes to 8.66, right? So after 0.0 has no value, so I have written 8.66 meters. That is the height of the tower. So asked width of the road and height of the tower. Those two, write it again. Therefore, the width of road equals to 5 meters. And the height of TV tower equals to 8.66 meters. Right. So with this we have completed. Pause the video and note it down or just take a screenshot. Now the second problem. A 1.5 meter tall boy is looking at the top of a temple which is 30 meters in height from a point at certain distance. The angle of elevation from his eye to the top of the crown of the temple increases from 30 degrees to 60 degrees as he walks towards the temple. Find the distance he walked towards the temple. Now here clearly see there is a temple here. Let me suppose this is the crown of the temple, okay? So usually draw with a scale, should not be crooked, use a scale, right? And the boy is just 1.5 meters tall. So in the case, if mentioned the height or the of a man, a person, a boy, girl or something, then only you consider. If not mentioned, we should not take that into consideration. Just eyesight is the point of observation, right? Now here mentioned 1.5 meters boy, that boy's height, okay, tall, he is that much tall. Now this is the temple, right? This is the temple, right? Okay, so this is the temple, and the temple is 30 meters. This temple is 30 meters of height. Here, now this boy, he has observed the crown, okay, the crown of the temple at an angle of 30 degrees, okay, at an angle of 30 degrees he had observed. Now he moved, okay, from here, because you have to take into consideration the eyesight, isn't it? And this is the horizontal line I have drawn. This is the boy, eyesight, we have drawn a horizontal line, right? From here he observed. So observing to the crown of the temple means clearly angle of elevation. So to the top, to upside, okay, so that is 30 degrees, and he moved some meters. Again he observed, then that has become 60 degrees given, okay. So he moved some towards the temple some distance. So question is asked is, this distance is asked, okay, this distance they are asking us to find out, right? Here we are given only 1.5 and this 30 meters, and if you clearly see that this is a rectangle, 1.5 here means the opposite side is again 1.5. Now here this I can calculate, this total is 30 meters, right? This total is 30 meters minus 1.5 comes to 28.5, right? Okay, this becomes 28.5 here. It has become clumsy, messed up, right? This is 1.5 meter. So out of 30, height of the temple, out of 30 minus 1.5 comes to 28.5. 30 minus 1.5 is 28.5. So this part is 28.5 and this is 1.5, and here we don't know this distance, right? We just don't know this distance. Let us suppose this as x. So how much distance he moved, and here see, we will suppose it as x. Let us give the names, like here this is AB is the temple, CD is the height of the boy, and he has moved to another point of observation. From C he observed, the angle was 30 degrees, he moved towards, so the angle will increase, isn't it? So at an observation point of E, he got the angle as 60 degrees. So this is the complete diagram. From this diagram, again we have two triangles, two right angle triangles. From these two right angle triangles, we are going to get the information. Now the information is here, find the distance he walked towards the temple. That's all. Just the distance he walked towards the temple we had to know, right? Here, distance towards the temple. That means only this part which I had mentioned it as x, right? Here, let me take this, let me suppose this as D. Let me suppose this as D, right? Okay. Now let's start. This is the second solution. Now let's take the triangle, and also while taking the triangle, let me suppose this A, B, C, D, E is over. Let me suppose this as H. Okay, H. So let us take in triangle ACH. In triangle ACH, clearly the bigger triangle, right angle triangle. Here, tan 30 degrees is equal to 28.5, that's the opposite and the adjacent, isn't it? So that I'll take tan 30 degrees is equal to, opposite is 28.5 divided by the adjacent. Now the adjacent side is this one. This is nothing but D, right? Let us suppose this as D. Now tan 30 degrees is clearly 1 by root 3. That is equal to 28.5 by D. Right, cross multiply. D is equal to root 3 into 28.5. Keep it as it is. Now keep it as equation 1. Right, stop J. Now let's take the other triangle. In triangle, see there, AE and H. AE and H. Right, here tan 60 degrees, again taken tan 60 degrees is opposite by the adjacent. So opposite is 28.5 by the adjacent is this part EH. Okay, EH. Let me write EH only. Right. Then the next part I'll write tan 60 is root 3 and 28.5 by EH. Now we did not mention EH as something here. We know this is X. We have supposed this as X and this as D. So from this we can see D minus X is this part. Right. EH is D minus X. So the complete D is the distance between this temple and the boy. And X is the part where the boy has moved. So D minus X is EH. So just cross multiply. D minus X into root 3 is equal to 28.5. Now we got here D as root 3 into 28.5. That we will substitute here. Here the D value is root 3 into 28.5 minus X. X is as it is, we'll keep, we don't know the X value. Just I have substituted the D value. Okay, write it here. Substitute D value. Right. Now this is equal to 28.5. Or else write substitute D from equation 1. Okay. From equation 1, what is D? We have substituted here. Right. So D, this much minus X is equal to. And now we will multiply this. We will open the bracket. Root 3 into root 3 comes to 3. So 3 into 28.5 minus again root 3x is equal to 28.5. Right. Bring this to this side and the x part to the other side. So 28.5 into 3. So let's do here 28.5 into 3. 3 5s 15, 24, 25, okay, 8, 85.5. That is 85.5 minus, bring this to this side 28.5 and shift this to the other side, that is root 3x. Right. Now this clearly 85.5 minus 28.5. So I am subtracting here. So this comes 15.7. So this is 57.0. So 57 equals to root 3x. Now I'll do it to the here the upper part. I'll do it here. Now 57 divided by root 3 is equal to x. Now x only we want. How much distance the boy has moved towards the temple, that has been asked, isn't it? Now 57. Now to cancel off root 3, 57 in the multiple of 3 we can write, right? 3 into 19 we can write it as 57 by root 3. So that I can cancel off root 3. Now 3 again I can write it as root 3 into root 3 into 19 by again root 3. Right. So 1 root 3 gets cancelled, that is equal to x. So 19 into root 3 value is 1.732. That is equal to x. Let's do that in the rough part here. 19 into 1.732 you will get, that comes to 32.908. Solve it in the rough part. So that is the final answer. X means the boy has moved. The distance the boy has moved. Find the distance he walked towards the temple. So this part is the rough part and this is the calculations what we had done. So this is, write that is in meters, right? In meters. So hence like this we can find out. Please pause the video and note it down. Now, I would like to show you an instrument like this is called as a clinometer. Right. Now, this is used to find the angle of elevation or the angle of depression. So, I will be giving to my students so that they can measure the palm tree in their schools or the height of the building, of the school building, like that, for the using of the projects. So, this is clearly a clinometer. And in the case of the second problem, if you see, the boy is, CD is the height of the boy, eyesight. Now, here, if the boy stands here, and from his eyesight, if he places here, this is hollow, this rod is hollow. From this, he sees towards the crown of the temple. Now, here, if you see this, it will be bent. If you are seeing towards like this, it is straight, and if you are seeing towards upwards, it will be bent. And clearly, this is used to measure the angle of elevation. Here, this is a protractor, isn't it? To measure the angle, we can use this. So, clearly we can use this, and after moving a distance of x is 32 meters. 32 meters he had moved. Again he saw, then when he saw here it was 30 degrees and he has moved towards the temple, it has become 60 degrees. So, this is a surveying instrument to measure the angle of elevation or the angle of depression. That is called as clinometer. Right. So, I was telling this in the introductory part, the surveying instruments and the clinometer. So, and also we can also measure the angle of depression standing on the top of a building. If you use the clinometer and see towards an object downwards, then you can easily find out the angle of depression. Hope you have understood these two problems. Now, we will continue the rest of the problems in our next session. Thank you all.